Hello, I'm Rebecca the Maths Lady, and welcome to this video which is all about teaching primary school children about temperature. In this video I'm going to cover how we teach children to have a really deep sense of what temperature is, how we teach them what units we use for it, how we measure temperature, and how we calculate with temperature. There are no particular videos you need to have watched before this one. I'll mention a few during the video that you might like to go back to if you find your children are struggling with particular points. Right, let's get started talking about how we give children a deep sense of what temperature is. Of course, the best thing to do is to start by asking them, what do you know about temperature? Gathering their knowledge together. And hopefully you'll quickly have a sense of temperature being about hot and cold things and what that means to your children. And then it's really powerful if you try to extend that a little, perhaps by saying the heat in something is a measure of the energy in the atoms and particles in it. To talk about how as humans we're really sensitive to the temperature range that goes from maybe a little bit below freezing water to body temperature and a bit above and maybe up to the boiling point of water. But below those cold temperatures and beyond those temperatures above boiling point, we'd struggle to really discern between different temperatures. And there are big ranges of very cold temperatures and big ranges of very hot temperatures. And you could ask them about things that are hotter than the boiling point of water. You could talk about how before people had temperatures to measure that high range, they would watch the colour change in metals as they got hotter. You might like to talk about maybe the temperature in the sun. And of course, it's really great to link this work into science experiments where you're measuring temperature, maybe into work on geography where you're considering the temperature and temperature ranges in different countries, or even into cooking. And I'll come back to that later. So we want to get children's brains firing so they're really thinking about everything they know about temperature and are connecting it together and expanding that before we start to do the maths of temperature. So the key units children need to know for temperature are degrees C, which is degrees centigrade usually, but it's also degrees Celsius. And they need to know that 0 is the point where water turns into ice or ice melts into water, and 100 is the point where water boils and turns into steam. And the more work we can do to give them a deep sense of that, the better. And then we call the scale centigrade because we're breaking that range of 0 to 100 into 100 parts. And centi is 100th, just like a centimetre is 100th of a metre. And as we explore all this, we need to introduce children to devices for measuring temperature. Now, one of the big problems we have is that they really need to see a traditional scaled thermometer, and there are very few about now. Very few children will see them at home. They usually have electronic thermometers, and of course it's really good if they do see an electronic thermometer, but we mustn't let them miss out on that stage of seeing and understanding a traditional scaled thermometer which has some kind of liquid in it which is expanding up a fine capillary, and usually the curvature of the glass around the capillary, but sometimes it's a mirror, expands that out so you can really see the liquid expanding up a scale. Here are some examples of some thermometers from learning resources that you could get for use in your class. This is a very large classroom thermometer. It's about 70 centimetres high. This is a set of 10 boiling point thermometers. So that's for natural climate temperature. These go from just below 0 to just above 100. And that's a standard climate thermometer. These are all by learning resources, and I've just picked them because they've created so many resources and I've always found them to be incredibly good quality. So as we use these thermometers, children will need to read scales. This one has a scale that's 50 and 5 marks later is 75. So they've got to read and understand those sections. Most of the thermometers I just mentioned had small sections, each of which was 2 degrees. And learning to read scales in context is a really important skill, and this is a great chance to develop that skill. Often in tests, children will see pictures of thermometers with these kinds of scales. Now, if they've only ever seen a digital thermometer, that's going to come as a shock. It's really important they've seen and touched and felt traditional thermometers. If you're getting towards the end of the year and you haven't got any and you haven't had a chance to do that, at least find a video so you've explored that with them to the best extent you can. So let's talk about calculating with temperature. Now what we can't do is multiply or divide temperature. It doesn't make any sense because 4 degrees centigrade is not 4 times as hot as 1 degree centigrade. That's because 0 degrees is an arbitrary point on a scale that goes much further. We actually go down to absolute zero at minus 273 degrees centigrade. And although in theory you could do multiplication and division starting at that point, in practice that's meaningless at this level. We are doing calculations where children have to work out temperatures, where they have a starting temperature and the temperature rises or goes down by a certain number of degrees. And that's really all about consolidating your work on your counting stick. So if we put 0 here and this is -2 degrees and the temperature goes up by 3 degrees, we get to 1 degree. And we want to make sure children can do that confidently. And the final calculation they need to be able to do is the difference between two temperatures. So if the temperature rises from 1 degree to 5 degrees, how much has it risen by? And it's also nice to cross the 0 point. If the temperature rises from -1 degree to 3 degrees, how much has it risen by? And it's really easy for children to make mistakes here because they have to count the gaps or the movements on the number line or the temperature scale. And that brings us full circle back to one of the first videos that I did for 7 to 11-year-olds on introducing the number line and how it is such a step change from discrete number that children deal with when they're younger, when each number is an object, to moving onto a number line. So if when you work on that you find that children are struggling and they're saying going from -1 degrees to 3 degrees is a change of 5 degrees, it's worth going back to that video to look at that again, and it delves into why some children find that difficult. So here's a link to that now. In this video I've moved on to assuming that children have an understanding of negative numbers. You can work on temperature, of course, without ever looking at negative numbers, but it's really nice to do. So if you've not looked at negative numbers with your children yet and you'd like to see that video, here's a link to that video now. And I did actually draw some thermometers in that video. Right, little bit of extension work. All of these thermometers also had a scale for Fahrenheit. Now we don't generally look at Fahrenheit on the primary school curriculum, but it's a nice way of consolidating work on formulae and also laying the groundwork for work on conversion graphs. So the formula for finding Fahrenheit from centigrade is this one. Your degrees Fahrenheit is 9/5 of your degrees centigrade, add 32. Now that probably looks a bit tricky for most of your students, so you can set it up like this. Centigrade times 9 divided by 5, add 32, gives you your temperature in degrees Fahrenheit. And provided you pick centigrade temperatures that are multiples of 5, children should now be able to work with this with a bit of guidance and generate some pairs of results. And you can set up the reverse machine if you like. Fahrenheit subtract 32 multiplied by 5 divided by 9 equals centigrade. And children can generate some pairs of results, and when they've got those pairs of results you can introduce them to a Fahrenheit to centigrade conversion graph, and they can start to spot their pairs of results on that graph, and then they can start to use that graph for converting temperatures that they haven't yet found results for. When you've done really thorough work in a particular context, you can take children on to a higher level, and that lays great foundations for when they come back to that topic as a topic in its own right, like the topic of formulae or the topic of conversion graphs. So there's plenty of great cross-curricular work on this. Of course, you can do science experiments where children need to measure temperatures. They love to just have a thermometer that'll go up to 100 degrees and to dip it in water as that water comes up to the boil, so they can see that for real, that the boiling point of water is about 100 degrees. In geography, you can talk about the climate in different countries and the temperature range, the highest and the lowest. You might want to set up a weather monitoring station outside that records that for you, so you can track the weather, and that's a great and a powerful thing to do. So your takeaways from this video are that you need to give children a really deep explorational multisensorial sense of what temperature is that connects their personal experiences into lots of wider information from the world around them. You need to make sure they become familiar with traditional thermometers, and it's really good to do a little bit of work on reading scales on thermometers. They need to understand the centigrade scale and how 0 is the freezing point of water and 100 is the boiling point of water. And we split that into 100 parts and centi means 100th. They need to do some calculations with temperature, but these are just about temperatures increasing and decreasing and finding the difference between two temperatures. That's it. We don't multiply or divide with temperatures. And it's great to work on some centigrade to Fahrenheit conversions as an extension to this. And we'd usually set up conversion machines step by step for going each way. And once we've got some results, we can look at a conversion graph and see how the pairs of results relate to points on that graph and how we can then use that graph to find other results. Thank you so much for watching. If you've got any feedback on this video or any suggestions for activities, please leave us a comment. If you'd like to see the full list of videos, that's available at www.authenticmaths.co.uk/videos. Please don't forget to recommend them to any friends or colleagues who you think might find them useful. But most of all, enjoy your teaching. Have a great day. Bye for now.